Welcome back, Geometry, to our next unit, quadrilaterals. The first of our quadrilaterals that we're going to talk about are called parallelograms. These are called parallelograms because the opposite sides are parallel. We're going to write parallel. Opposite sides are parallel. So when we see these opposite sides here, the symbol we use for parallel is the arrows on each one, and if we're meaning a different set of sides to be parallel to each other, we're going to put a different number of arrows on them. So I did this in green, but maybe it doesn't show up very well on camera. But you can do this just using the symbols, or you can use your own colors if you want. Opposite sides are parallel, so we call them a parallelogram. Now, in addition to that, the opposite sides are also congruent. Opposite sides are also congruent, which the symbol for congruence is just a dash mark. Okay? And we'll put a different number of dash marks depending on which pair of sides we are marking congruent. Once again, the blue doesn't necessarily show up very well on the yellow. In fact, it looks green. Blue and yellow together make that green color. In a parallelogram, not only are the opposite sides congruent, but the opposite angles are also congruent. Opposite angles are congruent. And if we think about what we know about parallel lines, that seems like it would make sense. Because if these are parallel to each other, they intersect those lines at the same angles. So those opposite angles are congruent, and these opposite angles are congruent. We'll put a different marking on them. And we can also say something about the consecutive angles. With parallel lines, we had consecutive interior angles that were supplementary. So the consecutive angles, since the opposite sides are parallel, the consecutive angles are supplementary as well. Consecutive angles are supplementary. So when we look at, and yellow won't show up on yellow, but we can just say that they're supplementary. And then one last thing about parallelograms, the diagonals, the segments that cut across the shape from one vertex to the opposite one. The diagonals are, the diagonals, they're not congruent to each other, but they do bisect each other. The diagonals bisect each other. The diagonals bisect. Okay. So what we can say there is, since this diagonal bisects that one and vice versa, this segment here and that segment there are congruent, as well as this segment here and this segment here are congruent. Okay. In red. So when we know certain measures, on our parallelogram, we can find some missing ones using those properties. So if we know that AB is 5, AB, that's 5, well then we also know that DC is 5. Opposite sides are congruent. So look at CD, also 5. BC is 14, BC is 14. Then we'll know that AD, also 14. AD, 14. If we know AC, that's a diagonal there, is 16. The diagonals bisect each other. So if AC is 16, then AE is half of that, 8, and EC also 8. So AE and EC are both 8. BE and ED, we know BD is 18. So BD getting bisected by AC splits that in half. 18 divided by 2 is 9. So BE and ED, both 9. What we can say about the angles. ABE is 41. Remember when we name an angle, we name the middle letter as the vertex. So angle ABE, this angle here, is 41. ABE is 41. We can actually use some properties of parallel lines to find some other angles. Since BA and DC are parallel, this diagonal is a transversal that creates these alternate interior angles. This one over here is also going to be 41. So angle CDE, angle CDE, D is in that middle there, also 41. So this isn't because the opposite angles are congruent. This is because those are alternate interior angles. Angle AEB, AEB, we don't know, hang on, AEB. I don't think we have enough information to find that one just yet. So let's find some other angles first. Angle EBC, I think it's a little bit blurry. Let's try that. There we go. Angle EBC, EBC is 25 degrees. So angle EDA, also 25 degrees. Those are alternate interior angles too. Which makes sense that these two together would be the same as those two together, because all opposite angles are congruent. And then angle BEC, here's BEC. I don't think I have enough information for that one just yet, so let's keep going. It's kind of a puzzle. If we don't have enough information to find one of the pieces, let's keep going and find other pieces. Here we got angle BCE. Change my angle there. Angle BCE, BCE, this angle here, 32 degrees. And angle DAE is its alternate interior pair, so it's also 32 degrees. So this angle here and this angle here are the same. And angle CED, CED, I do have, well, I almost have enough information here. Let's do one more, or let's keep moving. So angle ECD, ECD, that's that one there. We would need to know that angle before we can do that, maybe. Angle EAB, EAB, same story there. And DEA, DEA, we're going to need to know what that angle is. And I think we do have enough for each of these. Oh, we do have enough for this one as well. Maybe if we back up and look at the see if we have enough information for these other ones yet. Let's go ahead and let's look back at AEB. AEB. I think we're going to need to know that one first. So yeah, so let's still go back to ECD here. So angle ECD, this angle here. Notice that these two angles are going to be the consecutive angles with these two over here. So this big angle here is the 25 and the 41 put together. So that'd be 66 degrees. And this angle put together are going to be those consecutive angles that are supplementary. So these three angles here, or these four angles rather, these two plus these two are going to be 180. Add up to 180. So there's more than one way to go about this, because we could use these two angles here to find that angle, since those are part of the interior angles on a triangle. But let's use that new property, that these angles are supplementary. So we're going to say that the 66 degrees plus 32 degrees plus this degree here, the angle ECD, I'll call that x for now, plus x equals 180. Okay? Those consecutive angles are supplementary. We can add the 66 and the 32 together. 66 plus 32 is 96. 8. And then we can subtract to find that x is 82. So x is 82 degrees. And now that we know that, so angle ECD is 82 degrees, then the rest of this is going to just be a matter of subtracting from 180. So angle EAB, well, nope, we need to know one of these other ones first. DEA, how about DEA? Yeah, we can find that one. Angle DEA, this angle here, we have this 32 degrees, 25 degrees. We can say 32 plus 25 plus the measure of angle AED equals 180. Add those two together. 32 plus 25 is 57. And then when we subtract, we find that that measure is 180 minus 57 is 123. So 123 degrees for for DEA. Now that we know that, we know this one over here is also 123. The angle BEC. Angle CED is this one here. We can add the 82 and 41 and subtract from 180, or we can subtract 123 from 180 to get 57. So angle CED, 57 degrees. Notice that 82 plus 41, those are non-adjacent interior angles to that 123, which is an exterior angle of this triangle. 82 plus 41 is 123 as well. So that is another way to find that measure there. But vertical angles are the same. So 123, 123, 57, 57. And then for the angle of AEB, this one over here, EAB, we can add the 57 and the 41 and subtract from 180 to find this angle over here. And actually, we already found that one's 82, so this one here is 82 as well. The 32 and 82 put together to make that angle, so that one is 82. EAB is 82. Once we knew ECD, we can say those are the same. And then our last one here, AEB, AEB, we already labeled with 57 degrees. Okay, so, oops. Wasn't showing the bottom there. So on the bottom, 41 and 57 and 25 and 123, 32, 57, 82, 82, and 123. So each of these, we have a number of different relationships we can use in this picture. We have two sets of parallel lines that we can use. We have the diagonals that serve as transversals on those parallel lines. We have the consecutive angles that are supplementary. We have the alternate interior angles that are congruent. We have the vertical angles that are congruent. We have the linear pairs that are supplementary. We have so many different relationships we can use in here. The sum of the interior angles and triangles is 180. An exterior angle is the sum of the two non-adjacent interior angles. So lots of different ways we can find those missing values. We just need to connect the pieces together. Okay. So one more example. One more example here. We use those properties to find missing pieces. So this is not just one example. We're going to use this diagram to help us out for these. So if the measure of angle 1 is 22, what is the measure of angle 3? Well, angle 1 and angle 3, since this is a parallelogram, angle 1 and angle 3 are congruent. Those are alternate interior angles. So angle 3 is also 22 degrees. Just draw the relevant pieces here and then see that, oh, if these are parallel, then angle 1 and angle 3 are alternate interior angles. Measure of angle PMN is 60 degrees. So here's PMN, so that's that entire angle there is 60 degrees. entire angle is 60 degrees. What is the angle MPO? MPO. So this angle here is 60. This angle here is going to be the angle that is consecutive to it, and we just found out that the consecutive angles, the ones that are next to each other in the order going around the outside, are supplementary. So the consecutive angles, the 60 and this one here, add up to 180. 60 plus P equals 180. So then we can subtract to find that that angle is 120. So MPO is 120 degrees. The measure of angle 1 is 85 degrees. The measure of angle 2 is 40 degrees. What is the measure of angle MNO? So angle 1 and angle 2, those two together. Let's see, MNO is the angle that's opposite. So if angle 1 is 85, then 3 is 85. If angle 2 is 40, then 4 is 40. So those two put together are going to be the angle of MNO. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle MNO. The opposite angles are the same in parallelograms. So 85 plus 40 is 125. So 125 degrees. Now we can use these relationships too, as I just demonstrated. We can set up equations. We don't even have to know all of the values to do this. If we have parts of the expression that are variables or that have variables in them, we can still write an equation and then solve for the missing value. So PR is part of this diagonal. RN, the other part of that diagonal. Remember, the diagonals bisect each other, so PR and RN should be the same size. PR is equal to RN, so 3x equals 12. And then we can divide by 3 to find that x is 4. So what's the value of x? 4. Okay. We'll do these last 4 together in class. So see if you want to try to tackle those on your own and then check what we do in class, you can do that. Otherwise, we will do those together when I see you next time. Okay, bye for now.